I hope the screen is visible to everyone. So we'll get started with the first question. So the first question is says that uh, what is the maximum number of ties Rajesh has if his colleague saw him repeat a tie over the course of 5 days? Assume that Rajesh tends to postpone wearing the same tie twice by as long as possible. So let us see this problem like this. So uh, the colleague in the question observes Rajesh wearing uh, the same tie twice, that is, repeating in a course of 5 days. So let us draw the 5 days. So we'll have, let's say, this one, two. So let these be the 5 days. Okay. Now it could be that Rajesh has worn tie one on day one, tie two on day two, again tie one on day three, again tie two, and again tie one. So saw him repeat a tie over the course of 5. So this could be a one possibility. Other possibility could be that, let's say, he wore tie three on day three, tie two, and tie one. So this is also one more possibility. So in the question, it is asked that uh, we assume that Rajesh tends to postpone wearing the same tie twice by as long as possible. So uh, this gap, so let's say this gap, he tends to maximize it, or for that matter, this gap. So tends to postpone wearing the same tie twice as long as possible. So what is the maximum number of ties Rajesh has? So if his colleague see him postpone a tie over 5 days, so what do you think the answer should be in this question? You have four options, so four, five, six, seven. So what do you think is the right answer for this question? Four. So Akanksha says it's four. So can you explain, Akanksha, like why it is four?
So, cause he is not repeating the tie twice as long as possible. So, if we have four ties, then on fifth day he has to repeat the
Right,
original.
you are right. So in the figure that I have drawn over here, you see that the gap between tie one and the next tie one is four. So the this gap is 4 days, but this gap is only uh, how many? 2 days. So one, two. So we have to maximize 4. So what he does is basically he will stop, he will not wear tie 2 on day 4 and rather wear a different tie 4 on uh, day 4, and therefore this gap remains the highest, that is 4. So in a slot of 5 days, the maximum uh, gap that you can create between 2 days is 4. Therefore, the right answer for this question is also 4. So, 4 is the right answer. So, I hope that it is clear to everyone. It's a pretty simple, straightforward question. Uh, all right, we'll move on to the next question. So, in the following equation, uh, is the following equation true for all positive natural numbers up to n? So you have the sum of even numbers up to 2n, and they are saying that the sum is n into n plus 1. So what do you think? Anyone? Is it true or false? Anyone? Okay, what do you think of this? 1 plus 2 plus 3 up to n. What do you think the sum of n natural numbers is? Yeah, so someone says it is true. So the sum of n natural numbers. uh, Okay, someone is typing. Okay, someone is saying false. So if you look at the sum of n natural numbers, what do you think the answer is? I think Kiran Kumar has said it is false. Uh, is someone writing in the chat box? All right. So if you see the look at the sum of the n natural numbers, it is n into n plus 1 over 2. So this 2 plus 4 plus 6 up to 2n is basically you take these 2 from here and multiply on the left hand side and you get n into n plus 1. So this answer is true. So now, how does this come? So just to recollect how this comes, so we'll prove it by two methods. So first is the simple method that s- let's say s, you have this number, the variable s that denotes the sum of natural numbers 1 plus 2 plus 3 all the way up to n. You can again rewrite s as n plus n minus 1 plus n minus 2 and you add up to 1. If you take the sum of these two equations, if you add these two equations, so you get 2s as n plus 1 plus n plus 1 plus n plus 1. So all the sum will basically be n plus 1. And how many n plus such n plus 1 are there is n. So n into n plus 1. So s is basically n into n plus 1 over 2. Okay, just wait 1 minute. Mm. Okay, so this is one way of showing that this sum is n plus n by 2. There is another way that uh, is the inductive way of showing it. So since it is a discussion on mathematical induction, I'll just briefly show you how it's done. So we say that the sum of n natural numbers is n into n plus 1 by 2. So can we verify it? So let's say if we are saying that Sn equal to n into n plus 1 over 2. Now let us check the base step. So when uh, n equals to 1, so Sn equals to basically 1, but and according to the formula we have 1 into 2 by 2, that is also 1. If we take n equal to 2, what is Sn? Sn is 3. 1 plus 2 is 3. And it will turn out to be 2 into 3 by 2, which is again 3. So we know that this formula holds for steps 1 and 2. Now for the induction step, so for the induction step, So we let s k equal to k into k plus 1 by 2. So if we can show that sk plus 1 is equal to k plus 1 into k plus 2 over 2, then we are done. But we'll have to show this one. We have to do proof. So what we do is basically sk plus 1 is s of k plus k plus 1, which is k into k plus 1 over 2 plus k plus 1. So if we take k plus 1 common, we have k over 2 plus 1, which is nothing but k plus 1 into k plus 2 over 2. So we have proved it. So by induction also, this formula holds correct. So it means that this formula holds correct, and so we have proved it by two different methods, and if we multiply 2 on both sides, you get the sum of even numbers, which is nothing but n into n plus 1. So uh, does anyone have a question regarding the solution? Is is the solution clear to everyone? Uh, okay, then so we'll proceed to the next problem. So, what is the base case for the statement n factorial greater than 3n? So, in such a case, what they are asking is basically this, that find lowest n such that n factorial greater than 3n. So, what is the n beyond which, including that n itself, that n factorial is greater than 3 to the power n. So it is like basically if you draw the two graphs, maybe so 3 to the power n would look something like this, and this n factorial would be something like this. So this is n factorial and 3n. So they're asking us to find this point, this n star. So what is the base case for this n factorial greater than 3n? So this is a very pretty straightforward question. We don't have much to do over here. We just compare uh, the four values we have. So in ascending order, so we have, let's say, on one side, let us write n factorial, and on other side we have 3n. So for case, let's say 5 factorial. 5 factorial is 120, and we have 3 to the power 5, that is equal to 81. So sorry, 243. So 3 to the power n is greater. So this is not a base step. So this is wrong. Next, we have 6 factorial, and we have 3 to the power 6. 6 factorial is 720, and 3 to the power 6 would be 729. So it is very close, but still 3 to the power n is greater, so we'll have to ignore this. So we can see very well from here that 7 would be the next obvious answer. We don't have to compute it, but just for completeness, we do it. So for 7 factorial, it would be 5040, and 3 to the power 7 is 2187. So now in factorial overpower, so this is the base step. So the right answer for this question is 7. So if you are given such a question, always check in ascending order, and you will pretty soon get an idea for this. I hope this is clear. There is nothing much to this question. So we'll move on to a similar question like this. So you have n factorial greater than 2n where n is a positive integer greater than equal to x. So find x. So now we'll do the same thing. So we have, you have uh, n factorial, uh, and you have 2 to the power n. So we'll have to check for this question. We'll again have the same options that we had for the previous question. So just 1 minute. Okay, so we have n factorial. So if we take 5 factorial and 2 to the power 5, so we see that this 2 to the power 5 is how much? 32, and 5 factorial is 120. So in the very first step itself, we can see that uh, 120 is greater than 3. So we have uh, 5 as the right answer. So uh, what about 4? So let us see 4 factorial. So 4 factorial would be um, is 24, and 2 to the power 4 is 16. So again 4 is also a right answer for this question. What about 3 and 2 to the power 3? 3 factorial is 6, 2 to the power 3 is 8. So here uh, 6 is lesser than 8, so 3 is not. So 4 is the right answer. So n is a positive integer greater than equal to x. So base step, we have established that the base integer n equal to 4. Now we'll have to show that this actually holds true, that this uh, expression n factorial greater than 2n actually holds true. So next is induction step. Induction step. Let let n factorial, let, okay, so let's write this, let k factorial greater than 2 to the power k. So we'll have to show this for k plus 1. So now we have a base step. So we know for 1k there exists 1k for which this is true. Now let us go for k plus 1. So basically, if I multiply k plus 1 on both sides, what I get is greater than k plus 1 into 2k. Right. Now this is k plus 1 factorial greater than uh, 2k. So now you see this k plus 1. So since we have our base step at base k equal to 4. So k plus 1 is definitely greater than 2, right? So for any k that you pick above 4, so let's say for k greater than equal to 4. So if I take 5, so 5 plus 1, 6 is greater than 2. So for any k greater than equal to 4, k plus 1 would be greater than 2. So therefore k plus 1 into 2k is greater than 2 into 2k, which is equal to 2k plus 1. So therefore we have k plus 1 factorial greater than 2k plus 1. So this is the induction step, and we have the base step. Therefore we can show that this always holds true for n greater than equal to 4. I hope that is clear to everyone. So this is 4. this x equal to 4. This is the answer. Okay, let us move on to the next question we have. So, in an MMA event, N fighters fight with each other at any given point of time. There is at least two fighters who have fought equal number of games. True or false? So, okay. So this is a big question. We'll break it down. So let us write this first. So a fighter, any random fighter you pick, any random fighter among the N fighters will fight how many games? So, can anyone tell me, like any random fighter? I have this N fighters and I pick any random fight. What is the number of games that he has fought in? Can anyone take a guess? N minus one. So, okay, N minus one is the upper limit of the number of fights a fighter can have fought. So it could have fought zero fights as well. It can fight one, it can fight two, and it can have fought n minus one fights as well. Is that clear? Now, next question is this. So, a random fighter can have fought 0 to n minus 1. So, there are n possible type number of games a fighter can have fought, and we have n fighters. So, uh, now they are asking us that is it at least two, is it possible that at least two fighters who have fought equal number of games? What do you think the answer to this question is? So a random fighter can fight n n variation, n type number of fights. So we have 0 to n minus 1, so that adds up to n, and you have n fighters. So a fighter could have fought 0 fight games, could have fought 2 games, or n minus 1 game. So what do you think is the answer to this question? Is Can there be two fighters who have fought equal number of games? Okay, so Akanksha is saying yes. So can you take a guess why it will hold true? Because we have n boxes, so this number of fights the fighter can fight are, let's say, boxes n, and we have n fighters. So by pigeonhole principle, it does not guarantee that a particular box will always have two fighters in it. So that is what we are looking at, right? So uh, if you have, so there are n boxes. So boxes represent the number of games a fighter has fought, and we have n fighters. Now, if we place n fighters in n boxes, do you think that uh, uh, any box, it will be guaranteed that at least one box will have two fighters? What do you think?
So I think cause if a fighter has fought n minus one games, suppose, then no one can have fought zero games. So there are only n minus one boxes over here which are possible. Either zero or n minus one will be there. So I
Right.
think that's why.
Yeah, you are absolutely right. That is the correct answer. So if a fighter fought in minus one games, there can be no fighter with zero games. Right. So it means what this implies is that we have n minus 1 boxes in total. Boxes is the number of games a fighter has fought. So if a fighter has fought 3 games, he would be put in box number 3. So such that there are n minus 1 boxes. It could be 0 to n minus 2 or 1 to n minus 1. So it would be 0, 1, 2 to n minus 2 or 1, 2, 3 to n minus 1. So we have these two combinations. So n minus 1 boxes and number of, so if we place n fighters in n minus 1 boxes, we are guaranteed that one box will contain at least 2 fighters. And if there are 2 fighters, means at least 2 fighters have fighters fought equal number of games. So this is your pigeonhole principle. You, so using the pigeonhole we are using it here, and therefore this statement is true. So true, it is true that there will be at least 2 fighters who have fought equal number of games. Is this clear to everyone? Someone is typing some. Okay, I think it's clear. If you have a doubt, you can ask me at the end as well. Uh, okay, let us move on to the next question. So we use the principle of mathematical induction to find which of the following always divides 6 n minus 1, where n can be any positive integer. So if we see which always divides it, so right, if we take n equal to 1, that's easy to check. So we have 6 to the power 1 minus 1, that is 5. So we pick 5, let's say, and check that uh, whether this statement holds true or not. So we have a base case. So we have a base case. We know that uh, for n equal to 1, it is true. It is not true for any of the other. So for it's not divisible by 5, 7, 4, 7 or 9. It's only divisible by 5. So 5 is a possible candidate for the right answer, but still we have to prove the induction step. So for the induction step, let 6k minus 1 uh, equal to 5m. So it means that it is divisible by 5. Now it is a multiple of 5 basically. Now what about 6k plus 1? So 6k plus 1 minus 1 can be written as 6 into 6k minus 1. This one can be written as minus 6 plus 5. So if we take the 6 common, so we have 6k minus 1 plus 5. And this 6 we know that this 6k minus 1 is equal to 5m, which is a multiple of 5 plus 5. And so we can take 5 common, we have 6m plus 1. So this term is multiple of 5. Therefore, 6k plus 1 divisible by 5. And we have a base step at n equal to 1 and it is divisible by 5. So we can say that for any n, 6n. So therefore, for any n that's positive integer, so belong to z plus 6n minus 1 is divisible by 5. I hope this is clear to everyone. So the right answer for this question is option A. All right, so let us move on to the next question. So consider a following a function g whose domain is set x and codomain is set y. If the cardinality of x is less than cardinality of y, then which of the following deductions is true? Okay, so let us draw this sets to get a picture. So you have your domain x and a codomain that is bigger in size. So you have x and you have y. So G cannot be 1 onto G is onto G cannot be 1 1, G is 1 1. So it says that X has lesser number of elements compared to Y. So can anyone tell me, just for revision, what is a onto function and what is a 1 1 function? Can anyone unmute themselves and just tell me what is which function is which? Anyone? You can type in the chat box as well. Okay, what is an onto function? So if I write onto function, what does it mean? That okay, someone is typing, I think. Every Y has a pre-image. So yeah, so every element in codomain has at least one pre-image. It means that you have a element Y, let's say belonging to the set Y. It has come from at least one element in X. So it can come from multiple elements in X as well. So these are onto functions. Now let me check what is. Now let us discuss what is one function. What do you mean by one function? Anyone? What is a 1 1 function? Okay, so a 1 1 function is a function where every every element in domain has a unique image in codomain. It means this, that if you have an element x, it gets mapped to something in y. You have another element in x, it gets to another element in y. They are not mapped to the same element in y. And every element in x has at least one, has a unique image in y. So every element in x is covered. So now come to this question. So what do you think of this, which cannot be true? Now that we know what is a onto and a 1 1 function, and we know that uh, x is is smaller than y. So let us draw maybe four elements we have. Now, can you tell me which of the following A, B, C, D option is right? Can anyone take a guess? Okay, let me ask it this way. So, do you think that all of the uh, elements in Y will have a pre-image in X without uh, means it is a onto function? Can it be an onto function? Can anyone say so? Let's say I have this element, it gets mapped to this. I have this element, it is mapped to this one to this one to this. Let's say this one to this. Now I have left with two more elements, but an onto function will be such that all the elements in the codomain have a pre-image. Now what about this? Now we have covered all the elements in X. Now we have extra two uh, remaining. So what about I connect this to this? What do you think about this relation? Is it a valid function? Right, it is not a valid function. Why? Can you say why this line is not a valid function? Not valid function. Can you just explain why it is not a valid function? Right, so an element in X cannot have two images. So that is not the definition of a function. So if it has two images, then it can be a relation but not a function. Therefore, it is not a valid function. Now that you see that we cannot have lines like this, so what do you think that w- this function g can be onto? Is it possible for g to be onto? Okay, you're saying yes. So, can you give a case where do you think how it can be onto? If I do not have a line like this, so how will I connect? Let me name this functions. Wait, 1, 2, 3, 4, A, B, C, D, E, F. Can you suggest me a mapping where it is a onto mapping? So you cannot have any element in X cannot have two images. Uh, right. So it cannot be a valid function. So in such a case, it cannot be a onto function. So we'll have to remove such functions, and any other any other mapping that we draw will violate being a function. So these red lines will not be functions. Will not be functions. So therefore G cannot be onto. Can this be 1 1? So this option A is definitely correct. G cannot be onto. Can it be 1 1? What is your guess? So again I'll draw, let's say X, and I have Y. 1, 2, 3, 4, 2, 3, 4, 5, 6. So we have 1, 2, 3, 4, A, B, C, D, E, F. Now tell me, can this be a 1 1 function? Anyone? It can definitely be a 1 1 function, because 1 1 functions are basically concerned with the domain. So every image, every element in the domain must have a unique image in the codomain. So it can be anything like this. So you map 1 to B, 2 to C, 3 to A, and 4 to F. D and E are left out, but it doesn't matter as long as all the elements in the domain are covered, that is that they have a image in the codomain. It does not matter if some elements in the codomain do not have a pre-image. So this is a 1 1. Therefore the right answer is it cannot be a onto function, it can be a 1 1 function. So option A is the right answer for this question. Okay, now let us move on to question number 8. So Mahesh selects 7 whole numbers and claims that he will always have a triplet ABC which differs from each other by a multiple of x. What are the possible values of x among the options given below? So when we talk that two numbers are differing by a multiple of x. So let's say we have x equal to 5. When we say that two numbers are differing by a multiple of 5, what can we say about the remainders? Okay, let me write it this way. Two numbers We have two numbers, let's call them x1, x2, uh, such that x2 is the bigger one, x1. Now we say that x2 minus x1 is some multiple n of x. So what can we say about the what can we say about the remainder of x1 and x2 when divided by x? They will leave the same remainder, right? They will they will have same remainder. So basically, if how this comes is like this. So let's say x2 is n2 x some multiple of x plus r2, and x1 is n1 x plus r1. So r1 and r2 are the remainders. So we have x2 minus x1 would be n2 minus n1 x plus r2 minus r1. Now r2 minus r1 and r2 can take values from r1 comma r2 will belong to this set 0 1 2 x, right? Since we are dividing the number by x. Now if we take any two number in this set and take the difference, it will always be less than x, right? So this r2 minus r1 will cannot be greater than x. It will has to be always less than x. Now we have this. This is a multiple of x, and since this is a something less than x, so the only possibility is that this term is 0, so that the whole thing is a multiple of x. We are already told that x2 minus x1 is a multiple of x, and the first term is by default a multiple of x. The second term therefore has to be 0. Therefore r1 equal to r2. So any two numbers that uh, the difference of which uh, is a multiple of x will leave the same remainder on division by x. So we often write this term like this: x2 is congruent to x1 upon division by x. So this means that x2 comma x1 leave same remainder on division by x. Okay, now let us come back to the question that we have. We have this question that we know that this triplet which differ each other by a multiple of x. So what does this tell you about this triplet? So this triplet will a comma b comma c will leave same remainder on division by x. It I hope this statement is clear, that the triplet ABC will leave the same remainder on division by x because they differ each other by a multiple of x. So like we have shown here that if two numbers are differ by a multiple of x, they must leave the same remainder. So ABC will leave the same remainder. Now try to see this problem as a pigeonhole problem. So what they are saying that we have uh, three, we'll have at least three. So we have a hole, a pigeonhole that will contain at least uh, three numbers out of the seven. So how many boxes are there? So let us ask this question like this: how many boxes should be there to uh, ensure that uh, that at least one box contain that three elements upon distributing seven elements. So is this question clear to you? So now we have a different question to address. So we are asking that how many boxes should be there when we distribute uh, seven elements, how many boxes should be there such that when we distribute seven elements, at least one box contains three elements. So what do you think the answer to this question would be? So okay, what is the general pigeonhole principle? So if we have n elements and b boxes, what is guaranteed? So what is what is guaranteed that one box will contain at least how much element? Can anyone take a guess by pigeonhole principle? So at least one box will contain how many elements? NB5. So it is actually NB with a ceiling. So you uh, if n is 7 and b is 5, so n by b is basically 1 point something, 1.4. So if you take the ceiling, that would be 2. So at least one box will contain two elements. So this is the general uh, pigeonhole principle. Now we want to address this question. So how many boxes should be there to ensure that at least one box contain three elements upon distributing seven elements? So we have that on distributing seven elements, let's say there are B boxes, we have 7 over B. So this should be uh, greater than equal to 3. So uh, at least one box contains more than 3. So what do you think? Which values of B satisfies this condition? Can anyone take a guess? So B equal to, what are the values of B? So you have the ceiling function 7 over B. You take the ceiling and that should be greater than equal to B. So what are the values B can take? Okay, I'll write it like this. So you have B and you have 7 over B. So when B is 1, what is 7 over B? Anyone? It's 7, right? When B is, let's say, 4, what is 7 over B? The ceiling of 7 over B? 2, right? So 7 over 4 would be basically ceiling of uh, 1.75, so which is 2, right? What is ceiling of when B is 3? What is the value? What, 3, right? And if it is 2, then it's 4, right? So if we have 3, or if we if you see that B equal to 2 and 3 gives you greater than equal to 3. So if we have a number, so now let us address this question. So how many boxes should be there to ensure that at least one box contains 3 elements upon distributing to 7? So the answer is 2 comma 3. Is that clear? Yeah. So when we divide, if we have 2 or 3 boxes and we distribute 7 elements in these boxes, so at least one box will contain at least 3 elements. So it can contain more than 3 elements as well. Now come back to this question. So we are saying that A comma B comma C will leave the same remainder. So consider that leaving a remainder is like being in a same box. So when a number is divided by x, uh, remainder is 0, 1 to x minus 1, right? So we have this x boxes. So we have 1, 0, 1 to x minus 1. So we have x boxes, and we want to distribute 7 numbers in these boxes. Distribute 7 numbers in these boxes. If the number of boxes, now if you now look at this question, if the number of boxes is 2 or 3, then it is guaranteed that one of these boxes will contain at least 3 elements, which mean that we'll always get a triplet. So basically we have to find the number of box. So the number of boxes should be how much? 2 or 3? So option B and C both are correct for this question. Is that clear to everyone on why we solved this second question first and then went back to solving this question? Okay, I hope it's clear. Okay, so now coming to the ninth question, if there is a group of 6 people in the club, there will always be 3 out of them who are either mutual acquaintances or mutual strangers. What do you think? Is it true or false? So considering acquaintances and strangers to be symmetric relationships. So if A knows B, then B also knows A, and if A does not know B, B does not know A. So that is meant by symmetric relationship. So this is a big question. So we'll break it down into parts. So we have 6 people. So we'll call this 6. 1, 2, 3, 4, 5, 6. Now what we do is we pick one of them and we bring them here. So let's say this is a random person. So let this person be called X. I call it person X. So a person X can have either acquaintances or strangers. So any of these five persons that are left can be either stranger or acquaintance of X. So we have two boxes and five people. What does this tell you out of the pigeonhole principle? W- This person X, what is the what does the pigeonhole principle tell you about the number of acquaintances or strangers that this person X can have? Can anyone take a guess? Okay, so I'll tell it. So X has at least three acquaintances or three strangers. Is this clear to everyone from the pigeonhole principle? You have you have two boxes. So boxes are like this. I'll draw the boxes. So we have stranger and acquaintance, and we put uh, five people. We put five people in this boxes. So at least one of this box will have three people in it. Is that clear? So that is coming from pigeonhole principle. So using the pigeonhole principle, we can say that X has at least three acquaintances or three strangers. Now let us solve this problem by taking X into focus. So let us consider that case 1, X has uh, three strangers. Uh, so you have this X and you have a group with three people. So I'll draw red line means uh, X is a stranger. Okay, let me clear it. So right, right. Okay, so uh, let us draw like this that no line means stranger and solid line means acquaintance. Now, see, now let's say that we have X and X is not connected to any of the three strangers. Now, it could be that these strangers are connected among themselves. So, in such a case, we have uh, So this question asks that in a group of six people, there will be at least always be three out of them who are either mutual acquaintances or strangers. So here we have uh, three mutual acquaintances. Now now let us look at another figure. So we have x, and we again have uh, we have three uh, people. Now consider this, that at least if it is like this, that uh, two are connected, and but these two, and there is one link, at least one link missing. So in this case we'll have three people who are mutually three mutual strangers, right? In this case, so in case one, we have three mutual acquaintances, and if one of them does not have do not know each other, then we have three mutual strangers considering x as well. Similarly, we can show that the second case, x has three acquaintances. So we have x over here, and again we have three people. Now they are acquaintances, so therefore they will have this line in between them. So we have three acquaintances, but the three of them are not connected with each other, let's say. So therefore three mutual strangers. Again, consider the case, we have x and again three strangers. uh, Now we have three connections. Now if any one of them has a connection, then again we'll have this three mutual acquaintances. So therefore we have covered all the four possible cases that can exist. Therefore it is always guaranteed, so it will always be true that three out of them will be either mutual acquaintances or mutual strangers. So is this question clear to everyone? I know it is a bit complex compared to the other questions, so if you uh, have any doubt, you can ask. Okay, it's hopefully clear to you. So these are the only four possible cases that can uh, occur, and we have shown that in all of the four cases, there will always be a case where there will be either three mutual acquaintances or three mutual strangers. Coming to the final question, so we have seven unique integers that are chosen randomly between 6 and 336, including both 6 and 336. What is the probability that there is at least one pair of integers out of this seven whose difference is a multiple of 6? Again, this is a very similar question to the one that we solved. So whose difference is a multiple of 6? What does this line signify to you about the pair? So uh, what about the remainder of the numbers. What about the remainder of the numbers in the pair on division by 6? Can anyone take a guess? What would be the remainder of the numbers in the pair? So a pair has two numbers, let's say A and B. So what about the numbers A and B when dividing by 6? What is the remainder that is left? So they will be the same. So A would be A and B would leave the same remainder when divided by 6. So, and it could be like you mentioned 0, 1, 2, 3, 4, 5. So we have this 0, 1, 2, 3, 4, 5. So that gives us 6 boxes and 7 numbers. So we have 7 unique numbers are chosen and we are placing them in 6 boxes. So elements in the same box have same remain. Elements in same box have same remainder. So now can you tell me that uh, uh, is it always guaranteed that one of the boxes will have at least two elements? Yes, it is guaranteed. So uh, by pigeonhole principle, at least one box will have uh, two elements. Right. At least two elements. So that means that will always two elements means that we can form a pair. So there will always exist a pair. So we have all always there exists a pair AB such that A minus B will be a multiple of 6. So the what is the probability, since it is a shared event that it will always occur, the probability will be 1. I hope this is clear to you. Okay, so that brings us to the end of the discussions on the questions on the assignment. I have one more bonus question. So this is the question that is the quiz question that was discussed in the uh, lectures, but the answer to which was not discussed. So, did any one of you solve it? This question. So, if you are given 10 people, you'll always be able to find people in increasing or decreasing order. So, basically, you have. Did anyone solve it? So you have this 10 number. Let's say we have 7, 1, 3, 4, 2, 9, 8, 6, 5 and 10 maybe. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So um, wo- y- this question says that you will always be able to find four numbers which are in increasing or decreasing order. So if you take 7, let's say 7, okay, for 7 you won't be five. So if you let's say take this 1, 3, 4, and 9. So this is an increasing order. Similarly, you can find a decreasing order as well. So if you take uh, this 9, 8, 6, 5, so you have this sequence of four numbers which are in decreasing order. So has anyone of you solved this question? Or do you want to solve it on your own, and or do you want me to discuss it? Okay, so okay, since you're asking, I'll discuss it. So you have this 10 numbers, and you're saying that we can always pick four numbers such that they will be in increasing order and decreasing. So we cannot jump when we pick the four numbers, we cannot jumble the order. So these four numbers are also in order. So uh, four uh, numbers uh, have to be in order, have to be in order. So I cannot take that 7, 1, 3, 4 and form a increasing or decreasing sequence. That is not allowed. So we have been given this sequence. So I'll write this problem down. So given a sequence of uh, of 10 numbers, we can pick a subsequence of four numbers which are either in ascending or in ascending or descending order. This is the question that we want to solve. Now, uh, now let us see. So, how will we prove it that there exists a subsequence? We can always suppose contradiction. So let us prove. Let there be a So we contradict this statement that we can always pick a subsequence of four numbers. So let there, the contradiction would be let there be no in increasing or decreasing subsequence uh, of length four or more. So we are making this contradictory statement that there be no increasing or decreasing subsequence of length 4 or more, and then we'll show that this cannot be possible. This is how we are going to show it by contradiction. So for that, let us again consider this series. So we have this sequence. Let me write it down. 7, 1, 3, 4, 2, 9, 8, 6, 5, 10. Okay. Now, uh, let for each of this number, let us associate two numbers with it. So we have this is, let us call it I. This is I is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now we are associating a number I of I and D of I. So what does I of I means? So I of I is length of increasing sequence. Length of increasing subsequence, and di is length of decreasing subsequence. I'll show you with the examples. So let me fill this up. So I of I. So now what is the length of increasing subsequence is that from 7 we find the length of the subsequence that is increasing. So from 7 we go to 1, so it is not increasing, so only 1 value 1. So the sequence has only value 1. From 1 we see that it goes to 3, that is increasing. From 3 it goes to 4, that is also increasing. But from 4 it goes to 2, so it is not increasing. So we have the sequence length as 3, that is 1, 3, 4. For 3, we again see from 3 to 4 it is increasing, but from 4 to 2 again decreasing, so we have 2. For 4, it is not increasing, so 1. So from 2, it goes to 9, but then decreases to 8. So we have 2. From 9, it reduces to 8, so 1. From 8, it goes to 6, reduces, so 1. From 6, it goes to 5, it reduces 1. From 5, it goes to 10, so therefore we have 2, that is increasing, and 10, we have 1. Similarly, for can you say what the decreasing subsequence will be? Like similar to the increasing subsequence, can you uh, tell me what the decreasing subsequence would be? Take a guess. Okay, what is the decreasing subsequence of this number 7? What is the length up to which 7 is decreasing? 2, right? You're absolutely right. So it is 2 because we go from 7 to 1, it is decreasing, but from 1 to 3, it is increasing. So we don't want that. So decreasing means it's monotonically decreasing. So 7 and 1 are part of the subsequence. For 1, it is going to 3, it is increasing. So it is just 1. So for 3, it is going to 4. It is again increasing. So again 1. From 4 to 2, it is decreasing. But from 2 to 9, it is increasing. So we'll have only 4 and 2, 2. From 2 to 9, it is increasing. So we cannot have a decreasing subsequence. So 1. From 9 to 8, yeah. So you see from 9 to 8, it goes 1. From 8 to 6, again it is decreasing. From 6 to 5, again decreasing. But from 5 to 10, increasing. So here we have a subsequence of length 4. From 8 to 6, again we are decreasing. And from 6 to 5, decreasing. So we have 3. For 6, we have 1, and from 5, again we have 1 because 10 is increasing. And for 10, again we have 1. So we associate this number I and di. Now, is this clear to everyone? that how these values of I and DI are being associated? Is it clear to you? Because this is the crux of the proof. We'll use how these values of I and D to show that, to prove our contradiction. Okay, so one thing you observe from this subsequence, that is I or D, the capital I or D, they will at least have value 1, so they are natural numbers, so it will have 1 or more than 1, and similarly D will have 1 or more than 1, and it will all be natural numbers. Now consider this statement, that the contradictory statement that we made at the start of the proof. So let there be no increasing or decreasing subsequence of length 4 or more. So we see that there is a decreasing subsequence of definitely there is a decreasing subsequence of length 4 or more. Um, so, can anyone tell me? So, this subsequence, the way we calculated capital I and capital D are by uh, consecutive subs. Like these numbers are consecutive. So, I'll write it down for clarity. So, we say that it is consecutive numbers and consecutive. So it need not be like in this example. If you see this 1, 3, 4, and 9, this is an increasing subsequence but not a consecutive sequence. So uh, just because this number 4 does not occur in this array I, it does not mean that we do not have an increasing subsequence of size greater than 4. So we can see, like in this example, 1, 3, 4, and 9 is also a subsequence of length 4, increasing subsequence of length 4. So there is a difference between capital IDI and this, the actual problem that we want to solve. Now address this question. So let there be no increasing or decreasing subsequence of length 4 or more. This statement, this statement what does this mean? It means that I and DI less than 4 for all I. Is this clear to you? Why is it so that let there be no increasing or decreasing subsequence of length 4 or more? So if I and DI are less than 4, you cannot possibly have in actual subsequence that is greater than 4. So we are assuming that II and DI are less than 4 for all i's. Okay, so now actually what we can do is that uh, we let me make it simpler, so we don't keep this consecutive thing in between. It will be easier to understand, and so we modify this sequence a little bit. So what I say is that II is the length of the increasing subsequence and DI is the length of the decreasing subsequence. So for II, what I say that for number 7, what is the increasing length? So we have 7, then we have 9, and we have 10. So basically what I am saying that it need not be consecutive. We make it any subsequence. So 7, 9, 10. So this is a increasing subsequence. So we make it length 3. So for 1, so let me rewrite this just for uh, simplicity of understanding, otherwise it would become a bit complicated. So for 1, we have an increasing subsequence of 1, 3, 4, uh, 8, 10. This is 5. So we have 1, we have 4, we have 8, we have uh, 10. So if we included 9, that sequence would have been reduced by 1. So that's why we picked 8. So if we cannot pick 9 and 8 together, then the sequence won't be an increasing subsequence. So for 3, we have 3, 4. Again, we pick either one of them, 3, 4, 8, and 10. So we have 4. So for 4, we have 3. For 2, we have 2, again 8. And so for 2, again, we can do even better. So actually for 3 also we can do better. We, instead of 3, we have 3, 4, uh, 8, and 10. Uh, we cannot, once we pick 8, we cannot go back to 6 and 5. So I think it would be 4. So for 4, it would be 3. For 2, it will be 2, uh, 8, 10. So it will be 3. For 9, it will be 2, because 9 and 10 are the only left. For 8, it will be again 2. For 6, it will be 2. For 5, it will be 2. And for 10, it will be 1. I, I hope this one is clear to you. I made this change. I didn't make it consecutive. I made it any subsequence. So basically, now we are telling that if I and di less than 4, it means that there is no subsequence of length 4 or more. So just for completeness, I'll fill this up for uh, d as well. For 1, we have 1 because 1 is the smallest number. For 2, again, there is no smaller number than 2 on the right hand side, so it is 1. For 3, again, sorry. So I was looking at the wrong table. So for 7, we have a decreasing sequence of 7, uh, 4. If we take 7, 3, 2, that is 3. If we take 7, 4, we can't go, so it will be 3. So the maximum would be 3, again decreasing subsequence. 1, for 1 we cannot have, it will be 1. For 3 we can go to 2, so that is 2. For 4 we can go to 2, that is also 2. For 2 we always have an increasing subsequence, 1. For 9 we can go to 9, 8, 6, 5, so we have 4. For 8, we have 3. For 6, we have 2. For 5, we have 1. And for 10, again, we have 1. So this is now how we have changed it. Now, if I and di, so this contradictory statement says that I and di is less than 4 for all I. So what are the values I and di can take? I belongs to 1, 2, 3, and di belongs to 1, 2, 3. So this ordered pair I comma di will belong to this, let's say 1, 2, 3, 2, 1, 3, and so on. So let's say up to 3, 3. So how many elements are there in this? Can anyone take a guess? How many elements would be there in this set? 9, right? So there are 9 elements. So this I and di belongs to this set will have 9 elements. Now we have uh, we call this, okay, 9 pairs, and we call them that 9 boxes. So each, for any given sequence of number, for any given 10 numbers, I comma di has to be from, uh, for any number I, we'll have an ii and di, and has to be from one of the 9 boxes, right? So these 9 boxes refer to the 9 pairs. So let's say like this. If I pick, so if I pick this number 3, what are the ii's and di? So 4 and 2. So 4 and 2 does not exist in this because of this contradictory statement. But if it were to be present, so it would have been one of this pair from this. So let us take a more simpler case. So for, if we pick 2, we have 3 and 1. So 3 and 1 belongs to one of this 9 elements. So for every 2, so when we pick this number 2, we will put in that box, we'll put this number 2 in that box for which ii and di is 3 comma 1, and it is one of the 9 boxes that ii and di can have. Therefore we have, uh, therefore at least one box will have uh, more than one element. So what this means is that there exists a, a number k such that this ik equal to the number, a number ak. So we'll say like this. So there exists a number ak such that ik equal, uh, so for there will exist two numbers. Wait, this two numbers ik and ak and aj such that ik would be equal to ij and dk would be equal to dj. Right. Now, here we'll show the contradiction. So now tell me one thing. So you have this sequence. Let's say you consider this sequence. Uh, you have, these are the numbers are denoted by AI, and you consider this sequence, that three increasing sequence. So 3, 4, yeah. So we have increasing sequence. So if you see this increasing sequence, if a k, since ak and ak not equal to aj, if ak is greater than a of j, and the, and let us say uh, k is smaller than j and ak is greater than aj, it, what does this mean? That uh, the number on the left is bigger than the number on the right. So therefore this dk should be greater than dj, right? Do you agree with this, that if a you have two numbers ak and aj, since the numbers are all distinct, ak and aj are not equal, and k is less than j, and by pigeonhole principle we have ik equal to ij and dk equal to dj. Now if ak is greater than aj, it happens that dk should be greater than dj. Is that clear to you? Okay, I'll give you an example. So let's say this number aj is 5, and let's say let a k is equal to 7, and a uh, j is equal to 5. So it sequence looks like this. Something is there, 7, we have blank blank, we have 5, and let's say we have some 3, 2, and so on. So this part is your aj. Sorry, this sequence would be your dj, but this bigger sequence is your dk. So if the left hand number is bigger than the number on the right, therefore the subsequence, it will also be part of the subsequence, and hence dk should be greater than dj. Is that clear now? Oh, okay. So you're right. So it is dk. Now come to this other case. If ak is greater than a, now if it could be that ak is less than aj as well. So what would happen in this case? It would mean that ik is less than ij. Why? Again, let ak be 3 and a j be 5. Now we have 3, we have some elements, and we have 5, we have 7, we have 9. Let's say this sequence. So this sequence is your ij, and this sequence is your ik. So it would mean that ik is greater than ij, because since the left hand number is smaller than the this uh, sequence starting from aj, it would also be a part of that subsequence, and hence ik is greater than ij. So uh, if you look at these two examples, so ak and aj cannot be equal, so one of them should be greater and one of them should be less. So in either of this case, that d, if it is greater, then dk should be greater than dj, and if it is lesser, then ik should be greater than ij. So but these two conditions contradict this result. So this result, so this result we got from pigeonhole principle. We use the pigeonhole principle to get this result, that there will be two numbers ak and aj, where ak is, let's say, less than j, and ak and aj are not equal, such that ik should be equal to ij and dk should be less than uh, should be equal to dj. But since ak and aj are not same, we arrive at this condition that either dk and dj should be, there would be a difference in dk and dj, or there should be a difference in ik and ij. So that's the contradiction, and therefore there there will exist a increasing or decreasing subsequence of length 4 or more for 10 for a sequence of 10 numbers. I hope this is clear to you. I know it is a bit complicated and you'll have to look through it multiple times to get it clear. But if you have any doubt, you can ask me now. Or okay, so that brings us to the end of our discussion. So if you have any further doubts, you can ask, or we can close the session for today. And there will be a session tomorrow as well at the same time. And wish you all the best for this course. And we'll meet again next week. Okay, thank you. Bye.